Today we are going to be talking about energy. Please open up your blue Physical Science Review packet and turn to page 5. You will see that there is this image on your page. During notes today, what you're really going to be doing is you're going to be filling in each of these empty boxes here. So let's first start with this. Energy is. How would you describe energy? If you said that energy is the ability to do work, you would be correct. Anytime you talk about work being done, you have energy involved. So, in your note-taking sheet, you should write energy is the ability to do work. Now let's look at this in a little bit more detail. Let's look at the terms kinetic energy and potential energy. Look at the roller coaster picture below. How would you describe the conversion between potential and kinetic energy while riding a roller coaster? Let's identify these terms. Let's first start with looking at potential energy. Potential energy is the energy which results from position or configuration. So potential energy is really an object's capacity for doing work, but it's not actually doing work at that time. When you look at potential energy, what you're really talking about is stored energy. So when you think of potential energy, think about a stretched rubber band. The rubber band is stretched, it is pulled between two fingers, but it's not moving, it's not doing anything, it's just stretched there, right? It has the potential to move, but it hasn't yet. Now kinetic energy. Kinetic energy is the energy of motion. Kinetic energy is what we would call working energy. When you look at kinetic energy, that would be moving a finger and the rubber band flying through the air. So that potential energy, the stored energy in the stretched rubber band, has now gone into motion. And that's working energy. So when you look at this example of a roller coaster, when you have the cars moving higher and higher and higher on the actual roller coaster, their potential energy is increasing with elevation. Now, once they reach the very top of this hump, you would say that they are at their maximum potential energy. They have the most stored energy that they will have. The moment they go over the top of this crest and they begin to fall downward, well, now all of that potential energy is being converted into kinetic energy, right? That's where they go moving. So this is what you should have on your note-taking sheet. You should have that energy can be potential energy, which is called stored energy. Yes, I want you to write that on your sheet. And as potential energy is increasing, the kinetic energy is decreasing, meaning as you climb higher and higher up on your roller coaster, you have more and more kinetic energy decreasing as you go up on the roller coaster, and your potential energy is increasing. Once you reach the very top, you have the maximum amount of potential energy and you have the least amount of kinetic energy. The moment the car goes into motion and begins to slide down the track, now you have kinetic energy, and kinetic energy is the energy of motion. And remember, as your kinetic energy is increasing, meaning the faster you are moving, then, well, the less potential energy you have. Make sure you have all 4 of these boxes completed in your note-taking sheet. Now let's look at this. We looked at the conservation of mass earlier when we were looking at Introduction to Matter Review, and now let's look at the law of conservation of energy. Remember, to conserve something really means to save, meaning it cannot be created and it cannot be destroyed. So when we talk about the law of conservation of energy, what we're really talking about is the fact that energy is never created or destroyed. It's really just being converted from one form of energy to another form of energy. And you might be wondering, well, how many forms of energy are there? Well, what I'd like you to do is actually flip your page over in your note-taking packet, and you will see that we have listed 7 different forms of energy for you. Let's talk about these in a moment. Before I move on, though, I want to make sure Did you write in your note-taking packet, energy cannot be created or destroyed? Above that, I'd like you to write law of conservation of energy, just as a reminder to yourself. Okay, if you haven't already, flip your sheet over. Let's talk about the different forms of energy. One form of energy is mechanical energy. When you think of mechanical, you should think of motion, because mechanical energy is the energy of motion. Make sure in your note-taking sheet that you actually define mechanical energy. Now let's talk about this next form of energy, and that is heat energy. Another word for heat energy is thermal energy. And remember, when we talked about changes of state, we were actually talking about heat energy being added or heat energy being removed. And remember, we talked about that when particles gain heat, they actually gain movement, meaning that the particles begin moving faster. And we also talked about in changes of state that when particles lose heat energy, then they lose movement and they move closer together. So the same thing works when we talk about heat energy or thermal energy. Heat energy is related to the movement of particles that make up matter. These particles are called atoms, and they are always moving. The faster they are moving, the higher their heat energy. The slower they are moving, the lower their heat energy. Let's talk about this idea that atoms make up all particles. If we look inside of atoms, we have these things called subatomic particles. We have a nucleus made out of protons and neutrons, and on the outside of that nucleus, we have what's called an electron cloud. And electrons are what create electricity. When these electrons move, we have an electrical current produced. And electricity is a secondary energy source because it is generated by using a primary energy source, which we'll talk more about later. Let's talk about another form of energy, which is sound energy. Tomorrow we will talk about sound and light in even more detail, but for today, let's just review that sound energy happens because of vibration. So sounds vibrate against the air molecules, causing a wave effect. And this wave effect is then transmitted and picked up through our ears, and then our brain takes that signal and turns it into sound in our brains. Another form of energy would be radiant energy or light energy. Another way to look at this would be solar energy. And solar energy includes a lot of things. When we look at this form of energy, we're looking at light, we're looking at X-rays, we're looking at radio waves. All of these things, all forms of radiant energy, are crucial for life here on Earth. And let's talk about that breakfast you had this morning, or maybe you forgot to have. This is chemical energy. Chemical energy is energy that is stored in fuels. So it could be things like charcoal, like the coal that you use to burn fire, or in wood, or in gasoline, or in the food you ate or didn't eat for breakfast this morning. This is all chemical energy. And another form of energy would be that of magnetic energy. Magnetic energy is the energy that causes different types of metals to either attract or repel each other. Now that you've defined all 7 forms of energy that we can have here on Earth, let's flip our sheet back over. Because we're going to talk about how these different forms of energy can actually change. Energy can actually change from one form of energy to another form of energy. Remember how I told you energy is never created or destroyed, it just changes form? Well, we're going to look at that idea in more detail now. So look right here. Do you see how we have fuel? Do you remember what kind of energy fuel is? If you said chemical energy, you are correct. We take this fuel and we add heat, right? We burn it. And when we burn this fuel, we now create heat energy. So we have chemical energy now being changed into heat energy. This heat energy then begins to excite the particles in this water here. When the particles in the water now gain energy, they're going to turn into steam. Remember, this is a change of state. We have a liquid turning now into a gas. This steam is now siphoned off through a piping system. As the steam moves through the pipe, you can see that it actually turns and moves into an area where we have a turbine. Think of this turbine spinning much like you might think of the windmills that you see when you are driving down the street. So the steam actually begins to turn this turbine. So now what you have going on is you have mechanical energy occurring. And as this turbine spins, what you end up having is something that's called a generator spinning too. Really what a generator is it's a massive magnet that is spinning between a coil of wires. And when this magnet spins between a coil of wires, this magnetic energy actually excites the electrons in the wire. And you now know that when you have electrons that are moving, you have electricity. So what you've seen here in this image is how you can have something like chemical energy turned into heat energy, turned into mechanical energy, turned into magnetic energy, turned into electric energy. So when you think about a generator, what you need to remember is that a generator, that very last part of the picture we were looking at, so think of this, here's our generator. You have the magnet converting mechanical energy into electrical energy. So in your note-taking sheet, you should write that energy can change form. Energy can change from one form of energy to another form of energy, such as a generator turning mechanical energy, the spinning of the magnet, into electrical energy. Other ways to think of this is think about radiant energy or light energy being converted into chemical energy in a tree, which then produces oranges. The oranges now have chemical energy contained within them. When you eat or drink those oranges, orange juice for breakfast, you now have chemical energy inside of your body. The moment you take that chemical energy and you begin to move, you convert that chemical energy into mechanical energy. Here's some other examples. Think about an electrical plug. You plug it into a wall. When you plug it into a wall, you have electrical energy being converted into what form of energy in your oven? Or how about this? Look at this fish. What kind of energy is formed in food? When you eat the food, you then begin to move. This is mechanical energy, or energy of motion. What I would like you to do now is, on the very back part of your sheet, you'll see it says Energy Transformation Review Questions. What you're going to do is you are actually going to describe the different forms of energy transformations that are occurring. So, for example, question number 1 says, after lunch, a boy rides his bike to his friend's house. Remember that lunch, or food, is an example of chemical energy. So he would write, chemical energy transforms into mechanical energy, because remember, the riding of your bike is motion. Look at this next example. Question number 2. It says, a driver fills his car with gasoline. Remember that gasoline and food are the same form of energy. And then he drives 300 miles. So this is very similar to question number 1, because you have food, gasoline, fuel, charcoal. Those are all one form of energy. And whenever you have an energy of motion, you have another form of energy. Questions 1 and 2 will have very similar answers. Those are all the clues I'm going to give you. You will complete 3, 4, and 5 for your homework tonight, and I will be collecting and checking all of these tomorrow in class. Tomorrow in class, we'll be looking at solar energy panels, and we'll be playing a Pictionary game.